Hello everyone, I'm Tagda Kakkar and this is my channel AccelerateAICareers. Today we are going to discuss a very important and an interesting LeetCode problem. It's a hard level problem, LeetCode 76, Minimum Window Substring. So what does this question say and why is it important? So why is it important? Because it's been asked by several fan companies, Amazon, Meta, Microsoft, Google and Airbnb as well as Salesforce in their interview rounds in the last 6 to 12 months. It's kind of a very important question. What does this question say? So you have been provided two strings, one of S of length M and one is T of length N respectively. And you have to return the minimum window substring of string S such that every character of string T is included in it, including any kind of duplicates. You have to find like length of the window from string S of that substring which covers all the characters of string T. And if there is no such substring, then you have to return the empty string. Let's look at an example here. So first example, you have been given this string A, a dog code band, and your T string is ABC. So now if you see, there could be multiple strings where all characters of T are covered. So for example, if you start from the 0th index, you have a dog C where your all three characters are covered and then string length would be 6. But could we have minimum substring length where all characters are covered and the length could be less than 6? So let's look ahead. And you could have code B A, again the length is 6, but all characters are covered. Could we have even lesser? And we find a string band where all three characters ABC are covered, not in the same order, but they are there. And the string length, the substring length comes out to be 4, which is less than 6. So your minimum window substring length is 4. And the minimum substring window would be blank. So you have to return blank basically. Now let's look at example 2. Your input string is string S A and your T is A. You can of course deduce that you need one character, you have one character and that is A. So hence minimum substring length required would be 1 here and your answer would be A here. Let's look at example 3. So here your S is A, your T is double A. So there is no chance you would find double A in string S and then you return an empty string as an output because it couldn't find the occurrence of all the characters of T, including the duplicates in any of the substrings of S. So I hope the question is clear to you. The question asks you, could you find an algorithm that runs O of M plus N times to solve this question? So we have to find linear time complexity solution for this. Now let's look at some of the approaches to solve this question. Now what would be the brute force approach to solve this question? So we have all the characters as well as their counts in a hash map or a dictionary here for what we need, that is the characters from T and the count from T. And we can have a hash map for the characters from our string N and the characters count from there. We need to tally the count of only those characters which are present in T and nothing else, right? And we need to find the minimum length substring. That's our question. So we will always start from the 0th index and then move ahead towards the right. And we'll keep on checking whether our all conditions are met. That is, our count of A is equal to what we need. Our count of B is equal to what we need. Our count of C is equal to what we need. And our total count of halves is equal to what we need. That is the total count of needs. So that's our brute force approach. We'll start from 0th index and check. We find 1A. That means our count of A halves can increase to 1 now. So now it increases to 1. We'll check whether count of A is equal to count of A in need. Yes, it is equal. But does count of B is equal to count of B? No. Count of C is equal to count of C? No. So hence the condition is not met yet. Let's go ahead. So we are checking for these three conditions every time we move ahead. So now we go to the first index and we come across a character D. Does our count change? So no, our count doesn't change. We equate the count for A, B and C at every instant. Now we move another index. Now we come to index 2 and the character is O. Does our count change? Again we compare the three counts and we come to the character B. And does our count change? Yes, our count changes for character B. It becomes 1. Is count of character B equal to count of character B indeed? Yes, it is equal. So now these are all conditions meeting. No, count of C is less than what we need. So we move ahead. Now count of E, but we do not care about E character. Now we come across a C. Now our count of C is equal to 1 here. Is it equal to what we need? Yes, it is equal to what we need. Is count of A equal to what we need? Yes. Is count of B equal to what we need? Yes. So yes, we have found a window where all characters of T are there and their duplicates condition is met. And so we have a window of length 6. And we can save it in our result and move ahead and check if we find another window. The drawback for this question is that every time you are moving, every time you are going to the next index, you are checking for 3 conditions, whether count of A is equal to count of A of what we need, whether count of B is what count of B what we need, whether count of C is equal to what we need. So you will keep on checking those 3 conditions every time you move. So it doesn't lead to O of n time complexity because we are doing 3 checks every step you take. So it's not a linear time complexity solution there. Is there a better approach to solve this question? So yes, there is. So let me explain that approach. Now, what if we don't have to check for 3 conditions every time we move ahead? Can we check for 1 or 2 conditions to go ahead? So yes, there is a way. So say suppose you start from 0th index in this example and you check for number of conditions met. So you check for only one condition, that is the count of character you have come across. So A is one of those characters which is from string T. So we check for the count of just A and not the other character and we increment it by 1. But at the same time, we also increment one more count, which is the count of have conditions met. So our one count of have conditions met increases from 0 to 1 because we needed 1A and we have 1A now. So we only need 2 more conditions to be met. So we don't need to check for A again and again. Our one condition is met. We only need 2 have conditions to be met. And we'll only check for that particular character's count which we come across if it has occurred in T. So next we move to index 1, which is D. We don't care about it. Oh no. Then we move ahead and come across index 3, which is character B, which is a part of T's tree. So then we increment the count of character B from 0 to 1. And we also increment the number of have conditions met from 1 to 2. Since we have fulfilled 2 conditions, now there is just one condition we need to be checked, which is C. So we move ahead, we come across character E, which we do not care about. Now we move ahead and come across character C, which is at index 5. And our count of character C increases from 0 to 1. And our number of conditions met in have increases from 2 to 3. So every time we are checking whether the character is a part of substring tree or what. If it is, we check for its count. If it is met, we increment our have condition. And we do not go about checking the conditions which have already been met again and again. That is one change. Another change is now we are keeping a track of have conditions met, which we were not doing in our brute force approach. Now, how do we find the minimum window? The minimum window will not be found just by going ahead and checking. So to check that, once we have all the conditions met, we start omitting characters from the left side of the substring. So right now from string index and 0 to 5 is our result and our length of substring is 6. So we need to find something lesser than this. How can we find something lesser than this? We start omitting characters from this substring from 0 to 5 index from left side and see if our all conditions are still met. That is, our total count of have conditions met is still 3. So we omit character at index 0. As soon as we omit that, our count of A reduces from 1 to 0. And our number of have conditions met also reduces from 3 to 2. So now it is no longer an ideal substring. It does not meet our own condition. So we have to increment the characters from right hand side. We omit from left hand side and we add characters from the right hand side. So we add index 6, which is O, but it does not satisfy anything. We add index 7, which is D. It does not satisfy anything. Then index 8, which is E. So until now, the condition for this character has not been met. Again, we come across index 9, which is a B. So increment the count of B which from 1 to 2. But our number of have conditions met is still 2. Then we come across index 10, which is an A. So we increment the character from 0 to 1. And now our all conditions are met. But our result, should it be updated now? Now our result ranges from index 1 to index 10. It is obviously the length is more than 6, right? Do you want to increment the result? Of course, no, because we need a minimum substring. But can we omit more characters from the left hand side? So you can omit index 1, 2, even 3. and reduce the count of B from 2 to 1, then index 4. So if you omit these 4 characters, all have conditions are still met because you have one A, one B and one C. So your result is from length index 5 to index 10. But this length, if you see, of characters is still 6. So there is no change, right? But can you omit one character C? Let's remove index 5 character, which is a C. So if you remove that, count of C reduces to 0 and your have conditions math reduces to 2. So now it's no longer an ideal substring, right? So you start incrementing characters from the right hand side. So you start adding an N and then a C. As soon as you add the C, your count of C increases to 1, your number of have conditions increases to 3, and your all conditions are met again. So now your substring changes from index 6 to index 12, which is more than length 6, right? But can we omit characters from left? So we omit index 6, then index 7, index 8, and finally we have a 4th length character string from index 9 to 12, which meets our all conditions. It has the 3 characters from substring T in any order. So we can update our result from index 9 to index 12, and our substring length, minimum substring length will be 4. And we can return our result. So what is the crux of the solution presented here? Instead of checking for 3 conditions every time we increment our index, we are checking for 2 conditions, count of halves and count of character we come up. If it is there within T, okay? And we update our result only when the final length of substring we have found is less than the current length of substring which we had found earlier. And whenever we find a substring, we do not return it as an answer. As we check if we can omit characters from the left hand side and still fulfill all the conditions, that is, our have conditions is met, our count of characters is met. And if it is met, we keep on omitting our characters from left hand side. As soon as the number of conditions met for have reduces, count reduces, we start adding characters from the right hand side to find the same character we lost again. And finally, once we have come at the end of the string and we have the final length, and that is our best solution, then we return the indices. The indices 9 and 10, 12 would be returned. So this is our entire solution. We'll start coding it. If you have any doubts regarding it, ask them in the comments and we're happy to address it. First of all, we check for one edge case when your given string T is empty. In that case, if it is empty, what do? We just return an empty result. Okay? So that is your edge case. After that, you initialize your 2 windows, one for count T and one for your window, to check whether you have met all the conditions. Now, we initialize 2 dictionaries to track the counts of characters. So for tracking the count of characters in T, I'll see all 3 in T. I'll loop around the entire string T and I'll check count of T for character C and I'll increment it. So I'll increment it by 1 every time I come across that character. And how do I increment it? I use a Python function here, .get, because that character might be occurring for the first time or it might have occurred before. So I take a default as 0. If it has not occurred before, the default count it fetches is 0. If it has occurred before, it fetches earlier count. And then we increment it by 1 because we have come across the same character again. So it takes care of all the duplicates. Now we increment 2 variables have and need. So have initially will be 0 because none of their conditions are met at 0th index. And length of count T would be a need condition. Now implement your result and result length variables. Your result variable can be incremented to -1, and you can initialize it with any value. Result length can be by float infinity. You also initialize your left pointer by receiving, and now you loop around your entire string S. So for R in range length S, and then you check for this character at this particular index R. So how do you check? You first add it to window C. And how do you add it? Same as what you did for T, 1 plus window dot get C, 0. If it is occurring for the first time, 0 count will be fetched by get. If it has occurred before, the previous count will be fetched from the hash map and then 1 will be added to it. That's the entire window C. Now you will check if this character C is also in count of T and window C That is, the count of characters in window C is equal to count of TC. That is, your one of those conditions has been met. Then you increment your have condition met by 1. And this happens every time your one of those conditions is met. Now this way your count of T will get updated, your window will get updated, and your have conditions met will get updated accordingly. Suppose you have found one string which matches all your requirements, it has all the characters of T, and now you want to find the minimum substring. For that, what do? You omit characters from the left hand side and you add characters from the right hand side if any of the conditions is not met. So that's what I'm going to code here. So while have is equal to need, that is, your have condition is equal to need condition, you update the condition which I'm checking right now is if the current length of substring which I have found is less than the prior result length, because it might not be my first string which I have found, right? So I need to update result only when I find a length lesser than the prior length I found. So in that case, I update my result by L, R pointer, and I update my result length by R minus L plus 1, the length which I checked with result length, because it is less than result length. That's what I have found, right? Now I pop the element from left hand. How do you pop? So window SL, whatever is at the left index, that count gets reduced by 1. That's how you pop. You also will check if this SL was a part of T. So if SL in count T and bin SL, that is the current count of SL in window, is less than count of T SL. That is, no longer one of your conditions is being met because you omitted one character. In that case, you reduce your number of have conditions met by 1 and you implement your left pointer. And this loop will run until your have conditions is being met. That is, your number of have conditions is equal to number of need conditions. As soon as the number of have conditions is reduced by 1 and it no longer needs, it will go outside the loop, okay? And finally, you can just update your left and right pointers by the result, and then you can return the result. You return S of N until R plus 1 because it is offset by 1, right, in Python. So S N R plus 1, that is your result. But you have to check if this result length is less than infinity. It's not equal to load infinity, because there might be the case that all the characters of T are never found in string S. In that case, your result length will still be float infinity, so don't need to return that. You need to return empty string in case your result length is still float infinity. That's my entire code. I'll run it. It's accepted. It's submitted. It's working well. So the type complexity is O of n plus n, where m and n are length of strings s and n t respectively. So I'll quickly summarize the code for you once again. I first handled the edge case where my t is equal to empty string and I return an empty string because I don't have to find anything, right? Now I utilize 2 dictionaries, one for count t, one for window. And I loop around the entire t string to get the total counts. I use the inbuilt function from python.get so that if the current character is occurring for the first time, its count is taken as 0. If it has occurred before, its entire count is fetched and 1 is added to it. Now I initialize my 2 variables have and need. My have will be 0 initially, no conditions are met, and my need conditions will be length of count t. Now I initialize my result and result frame. So I initialize result by -1, that is the 2 indices -1, and my result length by float infinity. I also set my left pointer as 0. Now I loop around the entire string S using R pointer, and I keep on updating my window count similar to what I did for count t. After I have updated, I check if my both counts in count t and window are matched for a character C. If it matches, I increment by number of conditions met have by 1. Now while have is equal to need, that is my all conditions are being met, I start omitting characters from the left hand side. So I check if, first of all, I update my result. I check if R minus N plus 1 is less than the prior result length. If it is less, update the result and result length. That's what I have done here. And then I pop the element from the left side. So how do you pop the element from the left side? You reduce it left indices characters count by 1. That's what I've done here. And then you check if the count still matches, it's good, continue within the loop. If it doesn't match, then you have to reduce your number of hat conditions met by 1. That's what I've done. And you keep on incrementing your left pointer to loop around, okay? And finally, you return your result. You capture the result in left and right pointers. And you return your result as S of ranging from L to R plus 1. Plus 1 signifies the offset in Python. And then you return this result, you also check if your result length is currently float infinity or not. If it is float infinity, in that case you return an empty string. So that is it. The entire solution is this. If you have any doubts, ask them in the comments here. If you like my way of solving problems, subscribe to my channel. It keeps me encouraged to make more videos. I post one video daily and this will help you get your notifications for your daily LeetCode channels. Thank you.